What if I told you the digital world you interact with daily runs on a foundation of algorithms? Yes, algorithms. They are the silent architects, the invisible builders, shaping our experiences in the digital realm. They're not just lines of code, but a set of meticulously designed instructions with a defined purpose. They are the recipes of the digital world, each step carefully crafted to produce a desired outcome. Thank you for joining us here at Innovative Muse, where we explore the wonders of technology as a meets innovation. Welcome in. From the simplest tasks like sorting your emails to complex processes like predicting weather patterns, algorithms are at work. They guide search engines, power social media feeds, navigate us through cities, and even trade stocks on our behalf. Algorithms are not just integral to the functioning of computers and the internet, but they also play a pivotal role in shaping our modern society. They transform data into knowledge, chaos into order, uncertainty into predictability. Without algorithms, the digital world as we know it would cease to exist. Algorithms are the building blocks of any software or program. Think of them as a recipe, a step-by-step procedure to achieve a certain outcome. They're essential to the way our digital world functions. Now, you might be asking, where do we start? Well, the answer is simple, with the basics. Search and sort algorithms are the bread and butter of algorithmic thinking. They're straightforward, intuitive, and incredibly versatile. For instance, a search algorithm can help you find a specific email in your inbox, while a sort algorithm can arrange your music playlist from your most to least played songs. These basic algorithms epitomize the essence of algorithmic thinking, breaking down complex problems into manageable tasks. They are the first step in a journey that will take you through the intricate labyrinth of algorithmic complexity. The foundation of all algorithms is simplicity and logic. Remember, every grand structure is built upon a solid base. Why do some algorithms perform better than others? The answer lies in two key factors: efficiency and optimization. Like a well-oiled machine, an algorithm needs to be efficient, utilizing the least amount of computational resources while delivering the best possible output. Imagine an algorithm as a chef in a kitchen. An efficient chef can whip up a gourmet meal using the least ingredients in the shortest possible time. Similarly, an efficient algorithm can solve a problem using the least computational resources in the shortest possible time. Optimization is like fine-tuning that chef's recipe, tweaking it here and there to get the best taste in the least time. In the same vein, optimizing an algorithm involves refining it to improve its performance, reducing the time it takes to solve a problem or the space it needs to store data. Remember, the power of an algorithm lies in its efficiency. The more efficient and optimized an algorithm is, the better it performs. What makes an algorithm complex? Complexity is not about how hard an algorithm is to understand, but rather how it responds to increasing amounts of data. That's where complexity analysis comes in. It's a process that allows us to predict the efficiency of an algorithm, not just through intuition, but through mathematical proof. Imagine you're a chef in a bustling kitchen. The number of dishes you can prepare doesn't just depend on your culinary skills, but also on the number of stoves and the amount of ingredients at your disposal. Similarly, an algorithm's efficiency isn't just about the cleverness of its design, but also how it uses resources like time and space. This kitchen analogy is a simple way to understand something called Big O notation, a mathematical expression of how the runtime of an algorithm grows with the size of the input data. Complexity analysis is the compass that guides us through the labyrinth of algorithms. How can we solve a big problem? It's a question that has stumped many a mind, but fear not, for the divide and conquer strategy in algorithms comes to the rescue. This strategy is like a master chef, slicing a large unwieldy problem into smaller, more manageable morsels. Picture this: you're faced with a mammoth task. Instead of tackling it head-on, you break it down into smaller tasks. Each of these tasks can be solved independently, much like a self-contained puzzle piece. Once you've solved all the smaller puzzles, you simply piece them together to form the solution to the original problem. This strategy is not just about making problems manageable, it's about efficiency too. By breaking down the problem, we can solve each part faster and with less effort. It's like turning a mountain into a series of molehills. Divide and conquer, a strategy that makes the complex simple. How can we optimize the solutions to complex problems? This question leads us straight to a fascinating concept in algorithms: dynamic programming. This ingenious approach helps us find solutions to intricate problems by breaking them down into simpler, manageable sub-problems. Imagine a complex puzzle. Instead of trying to solve it all at once, dynamic programming suggests we break it down, piece by piece, solving each one at a time. We then store these solutions, and when similar situations arise, we simply refer back to these stored solutions rather than solving the same problem again. This saves time and computational power, making our algorithm more efficient. But here's the real magic of dynamic programming. It's all about thinking forward. By looking ahead, anticipating future problems and storing solutions, we set ourselves up for success. So remember, when faced with a complex problem, break it down, solve, store, and move forward. Dynamic programming, the art of thinking forward. What happens when an algorithm makes the locally optimal choice at each step? Enter the world of greedy algorithms. These fascinating decision makers operate on the principle of making the best choice at each decision point, with the hope that these local choices will lead to a global optimum. Imagine you're at a buffet with a plate that can only hold so much. You'd naturally start filling your plate with your favorite dishes, right? That's exactly what a greedy algorithm does. At each step, it chooses the most promising option, without worrying about the consequences. However, it's not always a bed of roses. Greedy algorithms may not always lead to the most efficient solution, especially when a globally optimal solution requires a series of less optimal local choices. But when they work wonderfully well, providing quick, efficient solutions. Greedy algorithms, because sometimes the best choice is right in front of you, can randomness lead to a perfect solution. It seems counterintuitive, but in the realm of algorithms, randomness is not just a wild card, but a strategic tool. Welcome to the world of randomized algorithms. Randomized algorithms leverage the power of chance. Instead of a set path, they use randomness to make decisions during their execution. This doesn't mean they're playing dice with your data. Rather, it's like a skilled chess player who uses a variety of strategies instead of sticking to a single, predictable game plan. In the world of algorithms, being unpredictable can be an advantage. Randomized algorithms can often solve problems faster or more efficiently than their deterministic counterparts. They can excel in dealing with large data sets and in situations where a good enough answer is acceptable. So can randomness lead to a perfect solution? Not always, but it can lead to some pretty impressive ones. Randomized algorithms where chaos meets order. What if an algorithm could learn from experience? Enter the world of machine learning algorithms, where this isn't just a hypothetical question, but a reality. These innovative algorithms are designed to learn from data, and the more data they're exposed to, the better they get at whatever task they're designed to perform. Imagine a toddler learning to recognize shapes. At first, they might struggle, but with time and practice, they become adept at distinguishing a square from a circle. Machine learning algorithms work in a similar way. They start off with a basic understanding, and as they process more and more data, they refine their knowledge, improving their performance over time. From predicting consumer behavior to diagnosing diseases, these algorithms are reshaping our world. So, whether we're aware of it or not, machine learning is becoming an integral part of our daily lives. Machine learning algorithms, the future of algorithmic design. So, what's the story of algorithms? We've traversed the vast landscape of algorithms, from their foundational principles to their strategic applications. We've dissected their efficiency and optimization, analyzed their complexity, and explored the divide and conquer strategy. We've unraveled the intricacies of dynamic programming, greedy algorithms, and randomized algorithms. We've also delved into the thrilling world of machine learning algorithms, demonstrating their profound influence in the digital age. Remember, understanding algorithms isn't just about comprehending a set of rules or steps. It's about appreciating the delicate balance between problem-solving and resource management. It's about recognizing the power of strategic decision-making and the potential of machine intelligence. Thank you for joining us on this journey through the world of algorithms. If you enjoyed this video, please like, share, and comment. Don't forget to subscribe for more insightful content. Until next time, be well.